Hello, everyone. My name is Charlie Berger. I'm the Senior Director of Product Management here at Oracle for Machine Learning, and I am going to be your host today for what I think you're going to find to be a very great TechCast. My background, by the way, is I'm both an Oracle employee, but along with Sham Nath, he and I are both the original co-founders of this analytics and data Oracle user community. And then over the last 15 years, we've worked with a number of hardworking volunteers to pull off these physical summits, now virtual summits, and a bunch of different things. And if you want to join into that and have some fun with us, then please send us a note. We'd love to have some more help here. Today, we're going to have a great speaker. It's Sai Karan. He's going to be talking about building predictive analytics solutions. More on that in a minute. After he's done, we're going to have a brief Q&A. I do want to do a little bit of housekeeping here. Our next TechCast will be, our next TechCast, I think, actually is, our last TechCast was June 4th, so you can go there and see that. But what we have coming up are, yes, TechCast days. Thank you, Sai. TechCast days, if you can scroll down just a little bit, is going to be 3 days of fun. Roger Cressy and I are going to be your skippers through a 3-hour tour of machine learning. We're going to have some great talks there with some various different customers. On day 2, I think we're doing all things Oracle, I believe it's spatial, and either spatial or graph. And on day 3, we're going to do all things, spatial day. And then on day 3, we'll have a 3-hour tour of Analytics Plus, and it's called Analytics Plus because we're not just going to be making pie charts. We're going to have some more fun than that. So you're going to have great speakers by experts and customer stories in their own words on those days. So please join us for that. Back to today's event. The speaker size, contact information is in the presentation. This event is being recorded. It will be available on the TechCast page shortly following the TechCast. We will also post a PDF of his presentation on the same page. We also post these TechCast recordings up on YouTube. So we're up to over 22 previously recorded TechCast out on YouTube. You just go watch a drill down on whatever topic you want to do. At this point, I always like to encourage you to submit a TechCast, whoever you are. Everyone has some amount of knowledge, expertise, tips and tricks. What worked, what didn't work. That's what we want to hear, not glossy kind of stories. To share their expertise, share their knowledge in using Oracle data and analytics technologies. We have a subcommittee that reviews these. There's a place on the website where you can submit them. We review them. And if you qualify and you have a good one, we reach out to you and put you on the schedule just like we've done for Sai today. More housekeeping. All the analytics and TechCasts are supposed to take about 30 minutes, and there is Q&A, but please use the Q&A. Use the Q&A button, not the chat. We try to encourage you to put in the Q&A button, not the chat window. So a little bit about our speaker today. Our speaker is Sai Karan. He's a passionate technologist responsible for the data sciences consulting practice at InfoLab. InfoLab is a leading digital consulting organization with a focus on cloud, autonomous database, Exadata, engineered systems, ERP, CRM, SaaS, and data scientists. And I think you're in for a fun ride here. I met Sai back just before our analytics and data summit that we did back in, I think it was the end of February, right? And he approached me. We got along great. I just loved what he was doing. I think you're seeing sort of the future here. You're seeing what is possible when you kind of use the converged database and all the in-database converged features and all the rest of the Oracle technology stack to do novel and interesting things. And I think what Sai is going to show you is going to be very good examples of that. With that, Sai, take it away.
Thank you, Charlie. Hello, everyone. Glad to be here. I will get right down to it. You have my LinkedIn connection, information there. Please feel free to reach out to me and connect to me, and I'll be happy to have a conversation anytime. My email is also down there. It's just sai@infolab.com. I think Charlie's already covered this. Definitely come in for the TechCast days. You're gonna have a lot of fun. It's 3 days of nonstop, great sessions. One quick slide about who I work for and what we do. We're a platinum partner of Oracle. We've been one of the strongest regional partners in the US for Oracle since 2009. Our focus initially was in the engineered systems space. We've kind of earned our chops there, and then we expanded to cloud SaaS implementations. We've expanded to cloud migrations, and now to data science. We have most of our consultants are based in the US. We're headquartered in Dallas. I'm based in Orange County, California. So that's kind of a quick introduction about who I work for. So I'll get right down to it. So there's several use cases. I was just thinking about how do we present this and how do we show, the process of building predictive analytics solutions. There's so many use cases out there. There's so many business problems to solve. If there's one takeaway for this session, it's about how do you put all the different pieces that Oracle offers you, right? And bring them together and build a fully automated predictive analytics solution that can solve real world problems, right? So we'll look at a variety of problems today. So my goal is to show you what the problem is, how Oracle comes together to solve, how you could put together the right architecture for solving these problems, and then the demo itself to say, you can actually see it perform live. What I'll also do is I'll spend at the end a few minutes going through the plumbing behind the scenes, right? In terms of how we prepare the data, right? How we run the machine learning models. So I'll show you a little bit of that as well. In the interest of time, that's pretty much what I can cover, but I'll be happy to share more information if you reach out to me. So the first use case that I think I'm going to talk about is EHR-based insights. Now, as you all know, you go to a doctor's office, the first thing you do is, they take your blood pressure, they take your, vital statistics, and they put it in a system, right? That's the EHR system, the electronic health record, or the EMR system, right? There's several big players in this market, Epic, Newgen, and so on, right? So the idea here is how do we use that data set, massive data sets, now to look at predictive analytics? So we've looked at a few things. We've looked at chronic conditions for one, right? So for example, diabetes, depression, asthma, hypertension, heart, cancer, right? These are all chronic conditions where 74% of the healthcare costs go into it. So if we can predict for a patient population, let's assume that you are a health system, right? And you have, let's say, 100,000 patients that you take care of. If we can look at that data set and say, out of the 100,000, maybe 10,000 or 5,000 are at risk for certain conditions. The goal here is to use population health, that is to say, okay, we can put them on a care plan and prevent those conditions from happening. So that's kind of the goal for what we are trying to do here with predictive analytics, right? Similarly for cost management, right? So let's assume that you have a ligament tear, right? You go in for a surgery. And you're fixed in 2 days, you're ready to get discharged. But for some reason, you pick up a secondary infection in the hospital. So now what happens is, let's assume you get readmitted within 30 days. The hospital has to pay a fine to CMS, right? To say, you discharge the patient. So the idea here is, if we can build predictive models to say, hey, listen, this patient is at risk for readmission, then the hospital benefits, right? There's several other use cases, real-time recommendations of treatment plans, right? There's many more, right? But I wanted to give you a sense of the types of problems that we're trying to solve with EHR data, right? Now, I want to get into the architecture itself, right? The first, as you can see, we're talking about various Oracle products here, right? And how do you put all of this together to build predictive analytics solutions, right? So we have EHR data coming in, right? We put it into the file storage system, which is the staging layer, right? That Oracle Cloud has. Then we use data flow to prepare it, to analyze it, and we store the data into the Oracle Autonomous Data Warehouse. Once we store the data in Oracle, after preparation of the data, we build the predictive models right there using Oracle ML. And the good thing about you can run Oracle ML both at this layer, the Oracle Autonomous Data Warehousing layer, and you can run Oracle ML models at the visualization layer, which is the Oracle Analytics Cloud. Oracle Analytics server, right, if you're on-prem. But we chose to do it on the ADW because we felt it was more efficient considering the large data sets. You can automate this using the Oracle Kubernetes engine. You can automate the whole process using, you can build in your CI/CD pipelines. You can do all of those things, right? So the idea here is, so Oracle gives you a full set here, right? And so what we've done is we have put these pieces together to solve for this use case. So let me kind of quickly jump into the actual demo itself to show you how it actually works. Right, this is a demo website that we have, right, just to show how does it work, right? I'm gonna log in. All right. So I'll start with diabetes, right? So here what I'm gonna do is, we can automate this process of loading the data, but here I'm manually uploading a data set. So the data set that we're working with, just to give you a sense of the scale, it has 90 million records. So it's a massive data set of patient population data, right? So this data set has encounter information, prescription information, all sorts of information, right? Clinical information, RX information, so on and so forth. So I'm going to start with diabetes to predict that. So essentially what I'm doing is now when I click upload, it's actually taking it, storing it to the file storage system, preparing the data, loading it into autonomous data warehouse, running the ML models, and then visualizing the results, right? So you're seeing this process happen now. So when I go back, the results are ready, right? So what you can see here is that out of this patient population that we looked at, about 24%, the model predicts that about 24% of the patient population is at risk for diabetes, right? So essentially, let's double click on that, right? And you can actually see what groups they are in. As expected, the majority of the patients are between 60 and 100, right? The male to female ratio, the race information. By the way, this is all de-identified data, so we don't really know who the patients are. We just have a patient ID. So that way it's completely secure. And we have the ways to approach how to de-identify data and so on, but that's a separate discussion, right? Now, if you look at it, the model looks at, we had about 140 columns, 90 million records, 140 columns. So the model predicts, so as you know, Oracle ML gives you the feature importance, right? So we look at, it tells you which features are more important for predicting certain insights. So the model that we've run identified these columns as being important to predict diabetes, right? So the BMI index, the DBP levels, the SBP levels, the size of the waist, alcohol group, whether how much they drink, so on and so forth, whether whether they have depression or not, what is the education level, and what is the family diabetes history. So interestingly, out of the 144 columns, these are the main ones that the model uses to, statistically it computes that these features are the most relevant ones, right? Now, our model right now is at about 93, 94% accuracy. So how can we test for accuracy, right? I mean, typically in data science, it's about, we don't want it to be a black box, right? Hey, trust the statistical model. It actually does its job. No, we actually want to make sure that we can prove that our predictive analytics is right. So we've also gone back in history. In this case, the way we test it out is we go back and compare the results against the blood sugar results for this particular patient population. So on the right side here is the validation section where we say, okay, you know what? This is the blood sugar results for A1C and FPG, which are the two tests that are run. And so we can actually comment with a fair degree of certainty that what the model is predicting here is relevant, right? So this is one use case, right? So how do you put together this particular architecture taken EHR data and actually solved for such use cases, right?
Hey, Sai, can I just interrupt for just a second?
Yeah.
There's been one question that came on here so far that says, will this be recorded? And we said that earlier on, that will be recorded. So who was, don't fear, you can get a copy of the whole thing. It's recorded. There's another question that just came in. I figured we just handle it real time. Maybe can you discuss how you determined those 4 columns were the most relevant? How did you narrow down those choices before doing the core? How did you narrow down to those 4 columns?
Right, good question. We actually don't determine that manually. The model determines it for us, right? So that's the beauty of using Oracle ML, right? So it kind of determines, it looks at all the historical information, and then it says, out of these 144 features, these features are the most important. So you can actually build feature ranking, right? So you can actually tell which, so by the way, you're not doing this. So it compares historical data. It looks at patterns, all the permutations and combinations, and it looks at, okay, these statistically, these feature sets is what is causing this particular condition to happen. So that's kind of how it does it. And what we do is we just display the top ones. Right? Is that okay, Charlie? Anything else?
Yeah, no, that was it. Thank you.
Okay. Okay. So let's go. I'll do one more, right? I mean, the depression is the same thing, right? So we have done it for depression, diabetes, and we can, I'll quickly talk about one more thing, right? It's slightly different here since we're in the topic of healthcare. This is for one of our clients who's a CRO. They do contract research organizations, and we are actually doing some POC for them. And the idea here is, so if you look at drug discovery, right? The goal of the drug discovery process for pharma companies, for all of these companies, is that they test millions of compounds, right? And say, are these compounds effective for a particular disease? So imagine if you are testing thousands and thousands of compounds, right? It's a pretty expensive process for clinical trials. So if we can use data science, if we can use predictive analytics to say which of these compounds are actually going to work, right? Or, we can narrow down the process of the whole clinical trial process, the drug discovery process, and speed up the process of drug discovery, right? And kind of, I guess this is a little timely because of COVID and things of that nature, and how we could actually meaningfully make a difference, right? So I'll kind of run one use case here. So this is for leukocytes. So essentially what leukocytes are is white blood cells. They act as the first line of defense. And so if you have a condition, they're the ones who go and investigate and say, is there something wrong here? And can we use the human system to fight the condition without any drugs, right? So the idea here is, how do you find compounds that can make the job of leukocytes, be better? So as you can see, we have, yeah.
Hey, so another quick question that I was going to field, but I figured it should come from you. People are asking, what are you making these dashboards out of? Is that Apex? Is it OAC? What are you using?
It's all OAC, right? So let me go back to the presentation mode, right? So if you look at it, think about it this way, right? So we're using object storage from Oracle to store the information. We're using data prep and data flow, that is for preparation layer. We're using the ADW for storing the data after preparation. We are building the ML models right here in ADW, right? And then we are visualizing, once the ML models are done, once the modeling is done, we're visualizing it in Oracle Analytics Cloud. So you could use Oracle Analytics Cloud, you could use Oracle Analytics Server. So there's several options there to visualize the data. Does that make sense? Okay. All right, so in this case, right, so for the drug discovery phase, so as you can see, only 1% of the compounds we predict are active. So it can make a huge difference in a clinical trial or a drug discovery process, right? About solving for problems, about solving for such data intensive models, right? So this is one other use case that I want to kind of talk about from a healthcare standpoint. There's several others that we've done, right, from to show how these things work. And you can automate all of this. The good thing is it's all, you can automate using OCI. So you can use Oracle Kubernetes, you can use your container orchestration systems to orchestrate the complete flow. So it gives you a lot of flexibility. And I'll talk a little bit about data preparation and how we build this. So I'll show you a notebook in terms of how we actually do these things, right? And how we actually build it. So I'll introduce two platforms there because I know you folks are interested in terms of what tools we use. So this is the Oracle Data Science platform, which gives you support for preparation of data, right? You can use Python, you can use whatever, tool sets that you have to prepare the data, play with the data, and then load it to autonomous data warehouse. Once you have the autonomous data, once you've loaded the data into autonomous data warehouse, you can actually use OML, that is Oracle's machine learning notebooks, right? So you can use these notebooks to train your models, run your models. You can do all of those things. And I'll walk you through these things in a minute. Let me go back to my, okay. All right, so that's kind of the healthcare piece, right? So there's so many problems that we can solve for. The idea here is we can use the Gen 2 infrastructure, we can use the ADW, we can use Oracle Analytics Cloud or Oracle Analytics Server, and we can build nice automated systems to solve for these problems, right? Okay. The next use case that I'll talk about is a little different. It's a security use case. So all of you, you're all Oracle customers, right? And you have, let's assume that you're using Audit Vault for your compliance needs, right? You have Audit Vault data, you have your log data, you have your Apache Access logs, you have your WebLogic logs, right? So Oracle Management Cloud offers you some solution to put together monitoring, right? But we extended it a little bit. So it's complementary to Oracle Management Cloud. And the idea here is, how do you predict real-time threat detection, right? So for example, you want to know if, let's say, an HR user is suddenly accessing financial records, right, using their own login information. Or you want to know if somebody from Africa is logging in and with the right credentials and they're accessing your tables. You want to know all sorts of anomaly pattern detection, right? So what we've done is we've built a real-time threat detection system using Oracle's products. And the idea here is there's a feedback loop. So you can actually go back and look at all the alerts that you get. And you can say, you know what, this is a false positive or a false negative or whatever, right? So the system learns, and every day it gets better in an automated fashion, right? So the goal here is to build a real-time security detection system, right? It doesn't it doesn't prevent the threats from happening, but it detects and it can tell you, there is something here that you need to take a look at, right? Because most of the issues we see in security is that people don't know they've been hacked. So the idea here is, if we can showcase this and say, you know what, you're able to detect, you're able to predict, not predict, but in real time, you're able to detect anomalies. That's a huge win, right? So we use classification models to actually do this, and I'll talk a little bit about that. So how do we do the architecture, right? What's the architecture behind this? So you have various data sources, right? You have Oracle data, you have ERP data, you have CRM data sets, you have all sorts of data, right? You have custom applications that you've built, everything is coming in. So we take and let's assume you used Audit Vault. We take the Audit Vault data, we load it to cloud storage. We use Oracle Functions, which is a serverless tool that Oracle has. So we trigger the ETL pipeline once it hits the storage using Oracle Functions. So again, this is another flavor of how we can use Oracle services, right? So we use Oracle Functions here. and when we start the PySpark ETL jobs, right? And then here I'm showing the compute edition, but we also have done it with the latest version of Big Data Service. But the idea here is to use the Big Data Service, look at all the jobs that are coming in, process it, load it to autonomous data warehouse, right? So then we again deploy our ML models on the autonomous data warehouse, and we visualize using Oracle Analytics Cloud, Oracle Analytics Server, right? Your choice, right? And so the idea here is all of these things fit in seamlessly. So now let me go and do the actual demo itself to see how this works. Right. So this is this is our demo website. So the idea here is, okay, now you're looking at security, right? So I'm going to load a security file which has audit wall log files, it has Apache log files, and it has WebLogic log files. Right? So when I'm doing the upload portion, right, it's loading the data into storage, it's preparing the data, it's putting it into ADW, and then it's running ML models and it's visualizing the results, right? So all of this is happening now in an automated fashion. So it takes a few seconds. So just to go back to the architecture, this is what's going on in the background. Okay. There's always some kinks, right, when you do a demo. So one
What makes it good?
It makes it good. It makes it real, right?
Yeah. Hey, Sai, just roughly, what's the order of magnitude of how much effort went into each of these things?
Good question. So for the healthcare pieces, so the good thing is, so let's say you want to tackle this. Okay, let me talk about security first because I'm on security, right? So this took us about a couple of months to build, end to end. Right. So the healthcare also took us, but we've done so many different things in healthcare. It's like, I would say if you take one use case, you should be able to do it in a month.
Cool. Very good.
Okay. So here's what we've done, right? So for the security piece, right? So now what we have done here is in a month, you can see what the threat level is. So we've given a security score from between 0 and 100, right? Again, all of this, what you're seeing here is our Oracle Analytics Cloud, right? So all the plumbing work happens in autonomous data warehouse, right? All the modeling, building, all of that happens there, and we use the beautiful pixel perfect visualizations that OAC and OAS offers. So in this case, so what we're saying here is, we're giving a threat level score, right, between 0 and 100, right? And so the day the threat levels are higher, then you want to take a look and see what's going on that particular day. We've also done security by threat levels, right? We've done low, medium, and high, right? So obviously you want to look at the high threats first. What we've also done is build geo mapping on this, right? We can actually look at a heat map and say, where are the threats coming from, right? So for example, you have New York, you have Michigan, you have the state of Washington, you have California, and so on, right? So you can go and say, okay, where are they? You can see which tables are being affected, right? You could look at malicious logins, right, to say, hey, where is the brute force login types? What's going on, right? And you can do this in real time, right? Any unusual URLs. So, for example, somebody's using different URLs to log into your system. Any unusual queries, like for example, let's say I was talking about it, right? You have an HR user who's running different kinds of queries, right? So you want to know why. You want to know after hours data spikes, right? You want to know what's going on, who's hitting the database, right? What's going on, you know. So these are all things that you can use to look at, you know, real-time threat detection, right? So malicious IPs, unauthorized requests, right? You want to see data volume spikes, database request rates, URL request rates, right? And you can actually look at the queries, right? So for example, I want to see, for example, you know, the high threats, right? Give it a minute to reconfigure just for the high threats. Okay. All right. In this case, it's still building it.
You want to try and field any questions while you're waiting for it to build it?
Yeah, sure.
You got a lot of good questions here, Sai.
Okay.
Here's one. Okay, what are the dashboards built in? You already answered that. How did you integrate the OAC dashboard in the web page?
So that's a whole different conversation.
And if you want to take some of these things offline or whatever, quick, you know.
Yeah, just shoot me a note and I'll be happy to explain how we integrated OAC onto the dashboard. So what we've also, just an interesting topic, one of the bigger problems we had was identity and access management. So while integrating OAC onto our websites, because we didn't want people to log in, go to have an Oracle session active and then come here and do all that. So we've used IDCS, Oracle IDCS, which is the cloud service, to actually authenticate and do that. So that these are problems that we've faced, right? And so,
well, just to finish that one, we'll save the rest of them for later on. He says the question is, how the security model working in real time, or is there any predefined time interval for reports refresh?
It's real time, right? So you could do streaming data, right? Or you could do batch data. So as and when the model comes in, so if you go back to the architecture, so whenever the data comes in and stores on storage, we can use Oracle functions to trigger the ETL pipeline, and you can see the results immediately.
Cool.
Okay, so now that this thing is done, right? Let's say I want to look at an unusual query, right? To say, okay, what happened here, right? So I double click on that again, right? Now what it does is it goes and looks at that particular day, a high security threat, and you can actually look at a query, right? Which query actually caused this issue, right? Who ran the query? So my apologies, we're having some connectivity problems. So we can do that, right? Do you have any other questions while this thing runs? Or should I go back to the? Okay, this is done.
Sorry,
so now
if you want another question or not?
No, I'm good. This thing
Okay.
finished. We'll take questions definitely. So if you can look at this, now for that particular day, you can see who was the username, what time they logged in, what IP address they came from, what team they were part of, what folders did they access, right? And you can even look at what queries they ran. So you have all the details here. Anyway, so this is a security model, right? But the idea here is to give you an insight of saying, okay, how can you bring in disparate data sources and build an automated pipeline here, right? To solve for predictive use cases. Now, let me go back. Now, the other thing I wanted to show you was that, okay, we've talked a lot about the cloud itself, right? So what happens if you're an on-prem customer, right? So you could do this all in on-prem too, right? And here is there's a blood bank, right? So their job is to go on blood drives and collect blood, right? So the idea for us is the idea here is to use predictive analytics to say, it's an expensive process. So if we can target the right donors, then you have better yield for the upcoming blood drives. if you can target the right locations and say, you know what, that location is ideal for a blood drive, and it can help them get better yield for their blood drives. So the idea here is to use predictive analytics and figure out who is probable to return, right? Who's going to come back, right? So you can do all of that, right? So now you can, like I said, I want to give you, I've done 2 with Oracle Cloud, and this is with your on-prem instances, right? So let's say you have a 19C database. It comes with data mining repository. You can use, right? You can use, it comes with all the ML models, so you don't have to go to the cloud. You could do it completely on-prem, and you can build these use cases, right? So let me go back and show you. So this one is the blood bank, right? Now, this is I'm showing this on the cloud, right? I'll show you the same thing on OAS, right? So this is the Oracle Analytics server, which you can run, right? And you will see the same dashboards that I showed you on Oracle Analytics Cloud, right? The good news is, let's say you're an OBIE customer, right? There is an easy upgrade path to Oracle Analytics Server. And in fact, I think, if I'm not wrong, Oracle recently, I think last month or so, announced that if you're like, please don't quote me on this, you can talk to Oracle about it. But if you have OBIE already, your licensing is covered, covers OAS as well. So you can get all the new functionality with your existing licenses, right? So if you can do that as well, right? So the idea here is you will see the same dashboards on OAS as you see on OAC. So in this case, these are, for example, we're predicting which locations to go for. So this is, again, we're using k-means clustering here, right? So we're looking at all the patients, where the donors are. We are using ML modeling to say, where should they have their next blood drive, right? So you could do that here, right? You can do a lot more, right? I mean, I will show you. So let's say return donor analysis. You want to analyze which donor is going to come back and donate blood. So if you're doing a marketing campaign and saying, and this doesn't apply to healthcare alone, you can do it for any marketing campaign, right? You want to predict who's going to be a repeat customer or who's going to do that. So the idea here is, if we could look at data and say, and predict which of those are going to return, it's a huge win, right? So for example, right, we predict that about 10% will return, right? And so we focus on those 10%, right? So it gives you a leg up in your efforts, right? And the same thing you can see in your Oracle Analytics server. You have the same thing on-prem as well, right? And you can upgrade from OBIE and you can get the same feature set.
So Sai, just to reiterate, you guys did this all in, like, for this blood bank one, like basically about a month.
I would say about a month and a half for blood bank.
That's impressive.
Yeah. So thank you. So I think the takeaway, right? I mean, I'm going to end here. Oh, I forgot. Sorry. I also promised to show you how we actually prepare the data and how we actually run the models, the plumbing behind the scenes, right? So what I'm going to do is I'm going to show you, this is the data science platform. So Oracle acquired this, I'm not sure when, probably a year or two ago, right? And now it's fully integrated. And it allows you to run your Python models. You can do all sorts of data preparations, right? So essentially what you're seeing here is your data science notebook, right? It's essentially the same as Jupyter notebooks. So we import the libraries that we want, right? We set the output views. Now, for example, this is a different use case, by the way, right? I haven't shown this use case. This is a use case for energy and utilities industry, Okay. So in this use case, what we are doing is and it applies to any manufacturing customers, right? So you have a machine, you want to know when it's going to fail, right? It's a simple use case. So it applies to multiple industries. So you have telemetry data, you have service data, you have usage data, right? You have weather data, right? You have all sorts of data. So the idea here is how do you bring all of those data sets? So you can see, right? So you can integrate it using APIs, or you could, in this case, we have just manually uploaded CSV files for telemetry errors, maintenance failures, machine data, and so on and so forth. So the idea here is, we take all of this information from disparate data sources, right? And this is the data preparation stage, right? This is where the hard work happens, because this is where we spend most of our time, right? In fact, Oracle has made it really easy to run ML models and visualize the data using autonomous data warehouse and Oracle Analytics Cloud. But this is where the grunt work happens, as all of you know, right? So, formatting the data columns, converting from string, because you get the data in certain formats, right? How do you create categories that you want to track? Then how do you create running averages so for example, in this use case, we want to know in the next 24 hours if a machine will fail, or in the next 3 hours a machine will fail, right? So it's a time-based average, right? So what we're doing here is we are taking data from all of these data sets, and we are actually computing for 3 hours and 24 hours, right? So the idea here is to prepare the data in such a way that when the ML model is applied to this data set, it can actually tell you, hey, is there going to be a failure in 3 hours? Is there going to be a machine failure in 24 hours, right? So merging the error data, right, with the telemetry data, right? Telemetry data is a sensor data, all of those data that you get on the machine, right? Then pivoting the error information. So we also want to know the maintenance schedule, right? You want to know how many days has happened since the parts or the components were replaced in these machines. So it's not about machine failure, right? We can actually predict component failure. So in a machine, you have thousands of components. We can actually predict which components in which machine will fail, right? So it's at that level that prediction algorithms work, right? Service data, right? How long has it been since the last replacement happened for these parts, right? And then we construct the data, right? We do labeling, right? So we label all the data sets and we build it, and we create our labeled features, right? So the label features are, you can see the voltage, rotation, pressure, vibration, all sorts of data sets, all sorts of data, right? So we prepare all of this data, label this data in the data science platform. And then once we have this data ready, then we move to the Oracle ML notebooks, right? So in this case, what we do is we actually build the table. So that we have taken the prepared data with labels, we build that in autonomous data warehouse, right? The same data set that you saw, the same prepared data that you saw there, right? In the data science notebook. So we prepare it here, right? We create the tables for running them so this is the testing data, right? So all the data preparation that we have is for training data, sorry, not testing. So the data preparation that we've done is for the training data. Then we build we define what models. In this case, it's random forest classification model, right? We look at the tree, what is the number of trees that we want to allow? 500. What is the tree depth that we want to allow? 5, right? So we can actually go down to this, we can define all of this very clearly here as in any notebook, right? And you can see the results here, right? Then we actually run the script to train the model, right? So as you can see, what mining function, what is the table name, right? Or the model name that you've defined earlier. So we do that. And then we have the results, right?
Hey,
And
Sai, we're running a little bit out of time, but are you able to share any of these files and notebooks, maybe in the analytics and data GitHub repository, or is this considered intellectual property of your company?
let me work on that, Charlie. Some of it is intellectual property, but I'll see what we can share. We'll definitely
Yeah.
give out a version of this.
Yeah, a
So
lot of good stuff here for everyone. Yeah.
Yeah. So in this case, right? So this is the confusion matrix aligned here, right? This is the confusion matrix. It gives you the efficiency of the models that we're running, right? So as you can see, the model, the efficiency is between 89 and 100%, right? Anyway, that's where I wanted to end my presentation today. So thank you very much. If there's one takeaway, you can, Oracle gives you all of these tool sets to build these things. So it's good.
Great job. You're pausing here.
Yeah, I'm done.
I know you have so much more that you could cover, but thank you. This is recorded for everyone. I love the fact that you went through all the different detail. We had a bunch of different questions. You've answered a lot of them about the data, the architecture, what you are using, the security. There was one about, are the models trained in real time or not?
It can be. It can be.
Can be,
yes.
but what else do we have here? You've answered a lot of them along the way. Oh, here it is. If the build time is about a month to put each one of these sort of verticals together, he wants to know how many hundreds and thousands of full-time people were involved.
Oh, no. This is not ERP or CRM type of projects, right? This is you're looking at one architect.
Like a couple of guys, right?
Yeah, about 3 guys at the most for each of these things.
Yeah, and I've met the guys. It's a good team. They did some great work. Let's see. I think we're pretty much out of time, Sai. Not that we couldn't go for hours. I mean, there's another comment here about absolutely fascinating stuff. Really appreciate this talk. All good feedback. We're just running out of time. So with that, Sai, can you go back to the TechCast Days page that we have? I just want to give one quick commercial for that before we wrap up. So everyone, we have even more coming. So July 7, 8, and 9, we've decided as the Analytics and Data Oracle user community, of which Sai is one of our board of director volunteers, along with a bunch of other hardworking people. We meet every week, and if you want to join that, tribe of fun, then please reach out to us. But we decided this year that the likelihood of having a physical Analytics and Data Summit out in California again in March was probably kind of questionable. So we decided, let's go for at least doing virtual, quarterly virtual summits. So the very first quarterly TechCast Days is what we're calling it, is July 7, 8, and 9 is the way you see it on the page here. And if you can just go to, like, say, the machine learning one, can you click on the registration, the Tuesday registration? Yeah. Just for example, this is the one I'm sort of on the subcommittee for this one. I don't know if it's in here or not, but we have, I guess maybe it's not in here, but we have UK National Healthcare System is going to present what they're doing. Fascinating stuff by Phil Godfrey and company. We have Barry Starkey from the Northgate Public Housing in the UK also talking. We have Philippe Leon talking about the Oracle Analytics Cloud and Oracle Machine Learning integration that's coming. And then we have Sandesh Rao talking about the machine learning behind the autonomous in the autonomous database. So that's just an example. On spatial and analytics plus days, you're going to have equally good talks. With that, anything else, Sai or Carrie, if you're out there, anything else? Otherwise, I think we'll bring it in for a landing here.
Sounds good. Thanks, everyone. Have a great rest of the day and enjoy your time.
All right, guys. Thank you. And watch the website for a copy of Sai's slides and the recordings and on YouTube. Thank you.